So actually in this case, because we have 2 points, A and B, this should be really easy. You happy? This should be really easy. Because we've got A, B, or O to B, is going to be given by 6, 4. Okay? So it's just really a case of putting that in the correct place. Okay? So I know that A is equal to, I'll write it down here again, 1, 1. I know that B is equal to 6, 4. Okay? So therefore, using this idea, any general point along this line, R, is going to be A, which is 1, 1, so A, plus some multiple of B minus A. Well, B minus A is going to be 6, 4 minus 1, 1. Happy with that? And I can fiddle around with this, so I get 1, 1 plus some multiple of 6 minus 1, which is 5, 4 minus 1, which is 3. Okay? Or if I really wanted to, I could write this as 1 plus 5t and then 1 plus 3t. I could also leave it like that if I wanted to as well. Or I could leave it in IJK notation. There's a multitude of ways which I could leave it. But as long as you understand this idea, it's not that difficult. Is that okay? Yeah, so in actual fact, the direction vector, so the vector equation of the line passing through A and B would be this. Okay? And you notice to get to different points along this line, all I need to do is change the value of t. Change the value of t. Okay? So for example, if I said that R is twice the distance of AB, okay, then I just stick t equals 2 in there. Or if I wanted 3 lots of that, that would get me to a different point along the line. If I stuck -5 in there, that would get me to a different point along the line. Is that okay with everyone? Now clearly in this case I've just used 2. I've just used 2 dimensions. And you're like, well, so what? Like I've got y equals mx plus c, I'm happy with that. But if you have a look at questions 3 and 4, that's now talking about 3 dimensions. In other words, I can get to any point in 3-dimensional space just using this idea of the vector equation of a line. Is that okay?